Hello and welcome to a review of the CS159 Spring 2020 final. This will be going over questions 1 through 27. If you have any more questions about the exam, you can view the announcement on Blackboard for a more in-depth overview. Additionally, I recommend that you either go through the exam yourself or at least pause the video and do the problems before I go through and explain them. I find that's much more helpful than just watching the video straight through. And lastly, if you have any lingering questions or if I have made a mistake, please make a comment on the video and I will respond and rectify the situation. Anyhow, let's get started. To begin with, for problems 1 to 3, we have a set of code with two functions, sort, pass, and find location. You might be able to guess that this is actually a sorting function or a sorting program. And let's just go down and see what the question is asking. Which of the following sorting algorithms is being implemented in the program above? Selection sort, bubble sort, or incision sort? This is something that is probably going to be featured quite heavily on the exam, is just understanding these different sorts and looking at implementations of them and the like. So we have to figure out which of the following sorting algorithms is being implemented. And we see that there's a main function that is looping through the array that's given. X is the name of the array. And it finds the location of a certain value in X, or runs this function, and then it sorts with the result of that function. So starting off, find location, and let's just say we're starting at the first position, which is 1. So it passes the array, it passes the I, and it passes the value of that array, so it would be 1 and 5. Now if we go down, for example, we have passing X, we have passing 1, and we have pass 5. So it says, is it greater than 1? Yes. And it checks if 5 is greater than the element before. In this case, it would be at index 0. Index 0 of the array is 3, which is true, so it returns start minus minus, or 0. So we're going to return 1. It's going to return 0. So it's going to return 0, and we have passed into sort pass 0, I is 1, and the array. We go to sort pass, and it's starting at start is 1 and end is 0. First it's setting temp to the value of start. This would make temp equal to what the value is at start, which is 5. And then it goes and it checks as if start's greater than end, which is true since 1 is greater than 0. And then it takes start and it sets it to what the previous value in the array is, which is, in this case, is 3. So it sets it equal to 3. And then it decrements start by 1 to 0. And it goes through it again, but this time 0 is not greater than 0 because start is 0, in this case start is 0 and end is 0. And then it finishes off by setting X's start, which is now 0, to temp, which is up here, so it's equal to 5. So we see here, and what this actually is doing overall is it's changing this to 3, and it's changing this to 5. So now we know what the code is doing through its first pass. We can make a judgment on what sorting algorithm is actually being used here. And the main giveaway is that there's a function called find location. And only one sorting algorithm actually searches for the correct location for an element, and that is insertion sort, when it's finding the location in which it wants to place the element. in this case, find a location is returning that position of where it wants to place the element. And then the sort pass is just shuffling over all of the elements until it gets to that position where that element should be placed. For this first pass, we can see that it's a little confusing because it only goes back one element. It only places it back one single position. But since it is finding the location and then sorting to put that element at that location, it is insertion sort. Another thing to note here is that there is especially this greater than and this minus minus, it's going through that location until it finds A. It's trying to find the spot. It keeps going while the number is greater than the previous number, and it also is decrementing that position. So it's going to be going from the greatest, or it's going to be going from the biggest element to the smallest element. So that answers our first question. The correct sorting algorithm is, in fact, insertion sort. And then question 2, which of the following values is found at index 0 when the sorting process in the program above is completed? Now, I just said that it's going to be going from the biggest element to the smallest element, so we have to look and find the biggest element in the list or this array, and it is 9. So the answer to 2 is going to be A. Now, a few more things that you can look at to try to determine, hey, how is this algorithm going to be sorting? Is it going to be going from smallest to largest? Is it going to be going from largest to smallest? And the way some of the key ways to look at it in this problem is to look at both that here, it's looking when it's looking for the location, it's not going from start is less than the size of the array. It's actually checking to make sure start is greater than 0 and then decrementing it. So you know that wherever the location is going to be, it's going to be to the left or to the beginning of the array rather than at the end of the array. It's going in that direction. And then another thing that helps you identify that is that start minus minus is also, it's decrementing the index instead of incrementing the index. It's going to the left. All right, moving on to the next question. Which of the following statements regarding the sorting process in the program above is true? A, the presence of duplicate values in the array will prevent the data from being completely sorted. That is false. None of the sorting algorithms we go over in the class, the common ones that we talked about, will prevent data from being completely sorted if there are duplicate values. B, the order of the elements in the array is unchanged by the first pass through the sorting algorithm. Well, we walked through the first pass of this algorithm and we saw that it changed the 5 and the 3. So that is, again, false. They are changed by the first pass. And then 3, the array will reach a sorted state prior to the final pass through the algorithm. Well, there's 2 ways of doing this. One of them is to actually go through all of the numbers and just see what the final pass looks like at that point. But that's going to take a while, and I'm going to go through a more logical route of thinking about what the final pass is going to look like without having to actually run through the loop and the sorting pass all 8 times or 9 times until we get to that last element. And we can see, first of all, that the last element, remember, this is going from largest to smallest values. It's not the smallest value in the array. 1 is the smallest value in the array. And a thing with insertion sort is that 1 is not going to be put at the end of the array. It's actually going to be ignored in this algorithm because if you consider that the sublist, the sorted sublist, is only going to be up to that number, it will think it's sorted, it will consider it sorted until it gets to that 2 and it realizes, hey, we need to shift that 2 with a 1. So in the final pass, 1 is going to be at index 8 and 2 is going to be at index 9, and it will have to swap those one last time for that final pass. So in this case, it asks if the array will reach a sorted state prior to the final pass through the algorithm, and that is false as well. So the answer will be D, none of the above, given they are all false. One last note is that if you aren't comfortable with how these algorithms work, it would be a good idea to review them to get a little bit of an understanding, to be able to run through them a little bit in your head, just to be able to go through the problems in the exam faster to facilitate your ability to do these kind of problems. My explanation for this is a little convoluted. It's a little hard to describe the actual iterations through the array itself. So I recommend you actually have a good understanding of the different sorts yourselves before the exam. All right, moving on to questions 4 through 6. We have a set of code that has another array of size 7, and it's looping through this array. So the question asks, which of the following is the first line of output generated by the program above? So let's go look at this output. This is the printf statement here. We can see that it's only triggered when the index is 2 or the index is 3, and that this is a for loop that loops through the array from 0 to 6. And so we are going to look at then the second index, which is here 43. We can see that there's a while loop here that is checking if 43 is divisible by the size, or if 43 is divisible by 7, which it's not. And so then it's going to be adding a number, which is calculated by taking the index and adding 1 to it, which is 3, and modulusing that by 7, which is going to be 3, as the lower number becomes the result of that expression. So it's going to be adding 3 to the index, to 43, until it is divisible by 7. Well, the next number that is divisible by both 3 and, not divisible by 3, the next number that is divisible by 7 will be 49. You add 3 twice, you get 49. And so the answer to this question is going to be that the number at index 2 of x will be 49. We scroll down, index at 2 of x is 49, so the answer to 4 will be A. Now for the following question, we have which of the following is the second line of output generated by the program above? And now we see that we're just doing the exact same thing, but with the third item in the array, the fourth item, index 3. And so we go through the same exact procedure, but with the fourth item. Again, this is now going to be 49. The fourth item is 30. Now notice I haven't talked about items 52, the first or the second elements in the array. And well, that's not because they aren't changed. You can see that it changes every single item in the array, but it's not actually printing those out, so we don't have to worry about them for now. The elements don't affect each other. Anyway, so we have 30. Is it divisible by 7? No. So we have to go through this procedure. We're going to add 1 plus the index, which is 4, modulus 7, which is 4. So we have to add 4 to this index until it is divisible by 7. The next number divisible by 7 is 42. If you add 4 3 times. So the answer to this question, to question 5, will be 42 at index 3. or answer C. Now the next question asks, which of the following statements regarding the program above is true? It asks, the data in the array will be sorted from the largest to smallest when the program terminates. It also asks, not every integer stored in the array will be unique when the program terminates. It also asks if the program will not terminate due to an infinite loop. So we can look here and we can see that all of these loops are not going to be indefinite. The for loop only goes through all of the elements in the array. The while loop is going to be adding a number that's actually less than 7 or equal to 7. It's going to be less than 7 to the element. So at some point that has to be divisible by 7. And so we know that none of these are going to actually end up in an infinite loop. So we can say that C is not true. Now, it's also asking us about if the array will be sorted from largest to smallest, and if the integers stored in the array will be unique when the program terminates. Unfortunately for this problem, I did not find a better solution than to just go through some of the indexes and see if you can find a case where you can prove this to either be true or false. So if we go through, we can go through the first two elements. Again, 30 becomes 42. So we have 52 modulus 7. And then this is at index 0, so this is 1. It gets incremented by 1 until it's divisible by 7, which would mean that the answer to 52 will be 56. And then we can look at 48. That's at index 1. Is 48 divisible by 7? No. Index is 1, so this will become 2. So it's going to be adding 2, which will also be 56. So now if we go down to 6, it asks, what of the following statements regarding the program above is true? And B states, not every integer stored in the array will be unique when the program terminates. And we just saw that the first element and the second element will be the same. So B is in fact true. So moving on to problems 7 through 9, we have another set of code. We have an array of size 8. We have a for loop that iterates through half of the array. This will evaluate to 4. And then prints the first index and the fourth index of the array. We have a change array function that is going to be actually adjusting elements of the array depending on the value of the element at the current index of the array. And we have a bit of logic there that will determine how much is added to that element at that new position. The first question asks, which of the following is the first line of output generated by the program above? We can see that it's trying to print the first value of the array. We can see that actually this second element does change that first element of the array, and we are looking at that through change array. We see that it starts at 0 and then it goes to 1. Alright, so for this problem, because this is an array and each value is actually adjusting the previous values. Alright, so to help me go through this problem, I'm going to be using a tracking table to keep track of the array as it is being changed in the change array function, and a bunch of elements get changed for every iteration through the array. The first iteration, you're going to be passing the array and the value, which is 3. So 3 and the array. So now it's going through the array, and it's going through all the elements that are less than 3, or so elements 0, 1, and 2. And for each of them, now it's going to set j to the value of the element at I, which is 3. So this is 3. And then it's going to add to the element at the index of j, which is the third element, which is 1. And it's going to add if 1 is greater than or equal to 7. And is 1 greater than or equal to 7? It's not. So it's going to increment that by 1, because this is the false condition. Again, size minus 1, I got 7, because 8 minus 1 is 7. So we're going to increment this element, which is the third element, by 1. So we're going to change this to 2, and we're actually going to update that in our tracking table here after that first iteration. Now we have to go through and do the same process with the elements 2 and 3, and then we have to go through all 4 iterations of the array, and I will do that off camera and then come back to you with the tracking table all filled out. Alright, so I've returned with the entire tracking table filled out, and this is not really an example of something that you'd want to do on the exam, but just something that you can check your work with to make sure that you were able to iterate through the array properly. So you start out with the original array here, and then you have to go through change array 5 times. The second time it does nothing. The end results, again, this was a lot of calculations, so I may have made a mistake somewhere in here, but I double checked my work for the values of 0 and 4 at position 0 and position 4 that are, double check that those are correct. So and they do line up with the correct answers in the exam, which are going to be that 7, x is 0 is 7. Question 7, the answer is 7, and question 8 is also 7. The value at index 4 is 7. Now the question number 9, it asks which of the following statements regarding the program above is false, and every element of the array is changed at least one time during the execution of the program. Well, we look at our array here and we can see that this is the second element. Element at index 1 stays at 0 throughout the entire array, and also that the 7th element, or the element at index 6, stays the same throughout the entire change array process, or through all the iterations, so that is actually going to be false. The next several indications: there's no index range violation during the execution of the program. That is true. The index of change array is always going to be less than the value that is taken from the array here, and in this case there are no values greater than 8 in the array, and they can never be greater than 8 in the array due to this last statement, so that is true. Option C, multiple elements in the array are changed more than a single time during the execution of the program. That's also true. We can look at the tracking table and easily see that, for example, element at index 4 is changed multiple times from 6 to 7. So these are both false, and the answer is A. Moving on, we have another set of code for the program for problems 10 through 12. This is another index. It's of size 9. Interestingly here, there are only 8 elements to find, so there's going to be another element here that is 0, just to remind you there. And it's going and it's adding, it's going through a loop where it says while I is less than size, while I is less than 9, it's going to increment the current value at the index, and then it's going to increase I by that value. All right, so if we go through this loop really quickly. Oh yeah, and the question is asking which of the following is the first line of input generated by the program above, so we're going to have to go through the loop regardless. And this is a much simpler loop, so we're actually just going to go through it on paper here. We don't need to make a tracking table or anything like that. So it starts out with I being 0, so it increments I by 1, so that's 3, and then it increments I by that value by 3, so now I is going to be 3. So we go to the third element, which is 0, and increments that by 1, so it's 1, and then it increments I, which is currently 3, by that value, so I is now going to be 4, so we go to the fourth element, or sorry, the element at index 4. And that is currently 1. We increment that by 1 to get 2. And we add that to I to get the next index, which is, the current index is 4, plus 2 is 6. So we go to 6, that's also 0. We add 1. We get we add that to the index, and it's currently 6. We go to 7, so now it's 7. We add 1 to that, we get 2. We add 2 to 7, it's 9. It's no longer less than size, so our final array, it becomes 3, 3, 4, 7, 2, 2, 1, 2, 0. So moving to question 10, which of the following is the first line of output generated by the program above? It is, in fact, 9. We calculated the last value of I to be 9, so the answer is A. Which of the following is the second line of output generated by the program above? That's the value at index 4, at index 6, and index 8. So 4 will be 2, 6 will be 1, and 8 will be 0. So 2 plus 1 is 3. And then the third line of output, which is the next question, what is the value at index 3 plus the value at index 5 plus the value at index 7? Well, the value at index 3 is 1. The value at index 7, oh, I should really fix that. This is actually a 1. That's not a 7. It looks a little confusing there because I underlined that. Is a 7. Sorry, it's not a 7. It's a 1. And so the value at index 3 is a 1, plus the value at index 5 is 2, plus the value at index 7, which is 2, which brings us to a total of 5. So the answer to 12 would be 5. Unfortunately, 5 is not an option, so we have to choose D, none of the above, as the answer to that question. Moving on to question 13, we're asked, given the array below and the array after 2 passes through a sorting algorithm, identify which of the following algorithms has been applied: selection sort, bubble sort, or insertion sort. When starting with one of these problems, I like to at least look at how it's being sorted. Is it being sorted from smallest to largest? Where is it, or is it being sorted from largest to smallest? And where is the sorting algorithm starting? Is it starting at the beginning? Is it starting at the end? Here we can see that it's taken the first 2 values, the 2 lowest values, and put them to the beginning of the array. We can see that technically these first 3 numbers are actually sorted, but it says 2 passes, so we're going to consider the sorted list to be stopped. This will be the sorted list, and this will be the unsorted. Now, the key to figuring out, hey, which of these is actually the correct sorting algorithm, both selection sort for sure will put the lowest 2 values there. Insertion sort we can actually cross off, because we know insertion sort is going to start with 21, and it's going to see that it's greater, and then it's going to go to 13, and it's going to put 13 before the 21. It's going to put 13 before the 14, but it's not going to reach the 12 after only 2 passes. So we can actually cross off insertion sort as an option. So we know it's either going to have to be selection sort or bubble sort, or more than one of the above. But the key to this is to looking at the leftovers. Look at what does the unsorted algorithm look like. The unsorted list look like, and that's going to actually change depending on which sorting algorithm has been applied. And in this case, if we were to go and do selection sort, we would see that it would find the 12 and it would switch the 12 with 14, so that the 12 and the 12 and the 14 would swap, and then it would find the second lowest value, which would be 13, and it would switch the 13 with the 21. All right, so then the order would be 12, 13, 21, 14, but we see that it is 14, 21 instead of 21, 14, so we know that it must be a bubble sort that is sorting the algorithm. Another way we can check that out is we can see how is bubble sort actually going to work here. It's going to change the 21 and the 13 on its first pass, and then it's going to change the 21 and the 12 again on that pass. All right, so it would be 14, 13, 12, 21. Moving on to the next question, we're asked which of the following would be the final values of the first and last variables when using the binary search with the array below given a target value of 45. So we can see that in this array it's already sorted, so that's good. That 45 is not in the array. And we know that when a binary search fails, that the index of the first variable, or the value of the first variable, is made to be larger than the value, it's made to be 1 greater than the value of the last variable. And in this case, the last variable will have to count the elements. There are actually 10 elements in the array, so it would be 9. And then we increment 9 by 1 to get the value of the first variable, and the answer is A. Moving on to question 15, it asks which of the following would be the final values of the first and last variables when using the binary search with the array below given a target value of 15. We can see this is again an array of size 10, and the target value of 15 is not found in the array. It's between 13 and 16. Now, if you remember how sequential search works, it will shrink the bounds of the first and last variables until they are either equal to or surround that desired value. So eventually first is going to be 0 and last will be 1, and then the midpoint will be 0 because it rounds down. And in that case, the result of the algorithm will be that the first will get incremented by 1 to 1, and that the last will be decremented by 1 to 0. So first will be 1, last will be 0, which is answer choice B. Again, if you're not comfortable with these algorithms, I would recommend that you become more familiar with them, maybe practice coding them a few times to get more comfortable. Moving on to question 16, given the array below, which of the following is not a possible configuration of the array after 2 passes through the selection sorting algorithm? So we know that there's 2 passes and that there will be 2 items in the sorted list after those 2 passes. In the first one, we see that it starts off with 20 and 21, which are the 2 largest numbers in the array, and it ends with 14 and 15, which are not the smallest items in the array. So we can assume that these first 2 are the sorted list, and that the rest are not in the sorted list. And that this particular implementation of the sorting selection algorithm is starting with the largest number first and going largest to smallest. Now for B, it starts with 14 and 21, so that's not the sorted list, but on the other end we have 13 and 12, which are the smallest values, so we can see the sorted list is in 13 and 12. Or is on the right. And then the last C, 14, 12, 13, 15, and 20 and 21. So we see the sorted part of the list is again on the right. Now we have to figure out which of the following is not a possible configuration. Well, just from these sorted sublists, we can see they're all appear valid. These 2 are going from largest to smallest. This one's starting on the left, these 2 are starting on the right, this one's going from smallest to largest. So we have to look at the leftovers, we have to look at the unsorted list to figure out which one is actually incorrect. And to save some time, you can go through the first 2 and you find that they are sorted correctly, but the last one is not sorted correctly, and it is not sorted correctly because remember that selection sort will swap the values and not do any shifting of the numbers. So if we look here, we know that it's going to find 21 and it's going to swap it with 15. That's going to be the first operation it performs. And then 15 would end up in position 1, or at index 1, position 2 of the array. And we can see in this array that actually 12 is at that position and 15 is in index 3. We can also see that 20 will not be swapped with any other number. It's already in the right position for this configuration. So the only numbers that should be swapped are 15 and 21, and for some reason 12 and 15 are also swapped. So this is not going to be a possible configuration of the array after 2 passes. Moving on to questions 17 through 19. We see some functions with some strings and some manipulation of the characters in those strings. The first question asks, which of the following is the first line of output generated by the program on the left? So let's see what it does. It creates a string that is final exam December 12th, 3:30 p.m. with string 2 being another string of the same size as the first string. And then it runs this function makeString with the first string and the second string. And then it prints using its own function, using these actually turn out to be index values, but 6 and 9 and 3 and 6. And then finally print the length of string 2. So if we go down to print test, I'll just go through this. It's basically, it has a starting value and an ending value. It prints the starting index. And then it goes through all of those inclusive, that range, and it prints that character from the array it was given. So now that we know that print test is basically just going to be printing the characters in that position of the string, we can look at makeString and see what's actually changing with those characters in the string. And we go here, we see it's looping through the string by the length of the string, and it's checking if it's alpha. All right, and then if it is alpha, it's going to set the position of that string in the second. And if it is alpha, it's going to set the current character at position count, or position CT, to the uppercase value of the first string. In this case, it's string and string 2. So again, it's going to set the character of string 2 at position count to the uppercase character of the first string at the current position. And then it's going to take the current character of the first string, and it's going to add the value of this expression, which you can see it checks as if it's greater than, or if it's less than or equal to m, it's going to return 13, and it will add 13 to that value. And if it's greater than m, it's going to decrease it by 13. And essentially there are 26 letters in the alphabet, so what this will do is it will shift the value of the character, and it will swap it with another character of the same type, either uppercase or lowercase. And so the original string is going to be a garbled version of the inputted string. So we go to the questions. It says, which of the following is the first line of output generated by the program on the left? We can see it gives us two options. It gives us a garbled string that is partial caps and partial no caps, a string that's all caps, and a string that's the original text. So we know that it's not going to be the original text because make string is in fact changing that original string. We know that this is checking if it's alpha, but it's not checking if it's uppercase or lowercase. And it's not changing it to uppercase. So if it's a lowercase number, it's just going to have 13 or negative 13 added to it. If it's less than, or if its uppercase equivalent is less than or equal to m or greater than m. So the correct answer to question 17, because this does not actually change all of those characters to uppercase, is A. And then question 18, which of the following is the second line of output generated by the program on the left? We have three options. We have AL space E, we have ALEX, and all uppercase, and we have ALEX, which is three different options, and it's a good thing to actually check, hey, we should check what part of the actual string are we looking at this index 3. So we count 1, 2, 3, and it's 3 to 6, so 4, 5, 6. So this is the original input, or what would look to be the input for this make string at that spot. And we can see what it does to the second string is that it sets it to uppercase. So we know that it's going to be all uppercase. So right now we're looking at B and we're seeing, okay, that's all uppercase, that makes sense. But hey, wait, isn't there a space in there that we should be looking at and we should be including? But if you remember, this only goes through and it only increments CT count if it's actually alpha. So if it's alpha, then it will add that. But if it's a space, then it's not going to go through this function and it's not going to add that space character. So the correct answer to 18 will be B. Now the third question, question 19, which of the following is the third line of output generated by the program on the left? And so the third line of output is asking, hey, checking the string length of the second string, and it's printing it. Now, we have 25, 50, and 14. Well, the original string was 50, so is the length of the second string 50? Actually, we've got to remember that, hey, it's only adding to that second string if it's an alpha character. If it's alpha, it runs it. If not, it doesn't run this code. It doesn't increment count. It will stay unadded, essentially. And string length, again, it does not actually count the size of the array. It just counts how many characters are in the array. So in this case, the answer is in fact going to be B, because it's only counting the alphanumeric characters in this string 2, which is only going to be the number of alphanumeric characters in the first string, which will be 14. Moving on to questions 20 through 21, we have some more string manipulation with a string that is set to variations of spelling on T. We have the string command, which checks for the occurrence of the second string in the first string. So if we look at this first line, actually, let's look at the question first. It asks, which of the following is the output generated by the first print statement in the program above? And what's that doing is it's printing a string that is pointer, and where does pointer get set in the previous line? It gets set to the output of string. String returns the pointer at which that element is first found, or that substring is first found in the first string. In this case, AEA is first found at position wherever that is at the end of the string. So the pointer will point to this element, and the result of printing starting at that element will be AEAEAT, which is answer C of question 20. Moving on to question 21, which of the following is the output generated by the second print statement in the program above? The second print statement is checking the final count value. Count is initially set to 0 after the pointer is looped through until it is null, where it's checking for EAE in the first string. So you can see it runs it first here outside of the loop, and it finds the first occurrence of EAE, which is actually going to be right here at index 1. It increments count by 1 because it found one occurrence of that, and then it checks again starting at the string that is immediately after that value. So then, for example, in the second string, EAE is going to show up here, all right, and then it's going to check the string that is immediately after that. So that's there, and that's going to check this string. Again, it can overlap. If it occurs multiple times but they overlap, that's fine because it's only incrementing 1 to the pointer. It's not incrementing 3, or the length of this second string. So it occurs here, it occurs here, it occurs here, and that's it. So it's going to occur 3 times. At the end of this, the pointer is going to keep being added until there are no more occurrences, and then string will return null, and the while loop will end. And so for, again, the number is 3 for the final count value. So the answer to 21 will be C. So now we have a few more questions about pointers. Which of the following statements regarding pointer variables is false? A, working with an uninitialized pointer variable is a compile time error. It is not a compile time error, it is a runtime error. That is why you get a segmentation fault. A lot of the times if you're writing code, you'll get segmentation faults because you'll overstep the bounds of your array, but you'll also get a segmentation fault if you are working with an uninitialized pointer, which, again, a segmentation fault, you don't get it when you compile it, you get it when you run your program, which makes it a little more bit difficult to debug. Let's go over why these other statements are true. The asterisk character is used in 2 different contexts for pointer variables, for declaration and for dereferencing. That is true. You use them when you're declaring pointers, and you use them when you're dereferencing pointers. The value of the pointer variable can change during the execution of the program. Yes, it can. There's an example of that in the code we just looked at. And none of the above is not true. 23 to 1 of the array. C, the dereference of an array name is the value of its first element. That is true. If you dereference an array name, it will give you its first element. So those are both true, and the answer to 23 is A. Moving on to questions 24 through 25, we have some pointer logic. It's asking for 24, which of the following is the output generated by the first print statement in the code segment above? And it's asking what is the sum of A plus B plus C. Now we can see that we have 3 variables and 3 pointers, so let's just go along through this logic here. First, it sets X to the address at A, so X is currently equal to the address at A. Y is now equal to X, so it's equal to the address at A, and then it changes what the value at the address of A is to 2. So this is going to change A is going to be equal to 2 and not 3. Now it sets X to the address of B. It sets Z to the address of X, which is the address of B. And then it sets Z to set the value at the address of Z to 7. So B is going to change to 7. And then it sets X to the value of C, which is, it sets X to the address of C, and then it changes that address to 11, so C is going to be 11. And now it goes back and it sets Y to 10, so instead of 2, A is going to be 10, because again, Y is still the address of A. And then it sets Z, which again is the address of B, to 9, so this will change from 7 to 9. And then the first print statement asks us what's A plus B plus C, and 10 plus 9 plus 11 is 13. The answer is 30. Moving on to question 25, it asks what is the following is the output generated by the second print statement, which it asks, hey, is the x equal to y, or is x equal to z? What's the sum of these two logical expressions? Well, x is equal to y. That's saying, hey, is the address represented by x equal to the address represented by y? And we know y is the address of A, and x is the address of C, so that's false, so this is going to be 0. And it says, hey, x is the address at x the same address that C? And we know that z is the address of B, and x is the address of C, so they're not the same, so we're going to say that's also 0. And 0 plus 0 result is 0. The answer to 25 is B. Alright, now to wrap up this video, we have 2 more questions. 26. Which of the following statements regarding dynamic memory allocation is true? A. The result of the malloc function is assigned to an array variable. That is false. The result of the malloc function is assigned to a pointer. So in this case, that is false. B. The value passed to the malloc function is the product of the number of elements to store and the amount of memory required to store a value of the given data type. That is true. To find the size of how much memory you need to store, you're going to have to multiply the amount of elements and the amount of memory required. Now C, which must be false, the memory allocated as a result of the malloc function is initialized to a default value based on the data type specified. That is false because the memory allocated as a result of malloc is not initialized at all. It is still just whatever the values in that position were before. So this is false. Now moving on to 27, which of the following statements regarding the searching algorithm studied this semester is false? A. In the binary searching algorithm, the first variable becomes greater than the last only when the target cannot be found. That is false if the first variable and the last variable are right next to each other and one of them is in fact the target, then the first variable becomes greater than the last and the target is found. So A is your answer. B. To determine a target value is not found in an unsorted list while using a sequential searching algorithm. Every element must be examined. That is true. And C, in general, the use of the sequential search is limited to small data sets or those that are not searched often. That is also true because sequential search is very difficult on the resource usage. Alright, so that wraps up questions 1 through 27. I should have questions, the rest of the exam, questions 28 through 50, up soon, depending on how long it takes me to record and edit it. If you have any questions or if I've made any mistakes, please put a comment in the video and I will do my best to fix it.